Good evening, students. This is the last lecture of this chapter, playing with numbers. In the previous two sessions, we have solved exercise 9a and 9b and 9c also. So some remaining questions are left from exercise 9c. Today we will solve the remaining questions and this chapter will complete. So before proceeding to questions, we have discussed some divisibility rule, that is divisibility rule of 2, divisibility rule of 3, divisibility rule of 4, 5, 6, and some divisibility rules are left, that is we have discussed the divisibility rule of 11 in this session, the divisibility rule of 15, the divisibility rule of 5, and also the divisibility rule of 10 here. Clear? Then we will proceed to our questions. So at first, the divisibility rule of 5. What is the divisibility rule of 5? Any number which has unit digit 5. Any number which has unit digit 5 or 0. Unit digit should be 5 or 0. Any number should be unit digit as 5 or 0. The unit digit should be 5 or 0. That number is divisible by 5. Clear? So let's take a number like 15, like 10, like 225, like 20, like 305. All are divisible by 5 because their unit digit is either 5 or 0. Unit digit is 5, unit digit is 0, unit digit 5, unit digit 5, unit digit 0. That means if unit digit is 5 or 0, that number is divisible by 5. This is the divisibility rule of 5. Clear? Next, a divisibility rule of 10. Divisibility rule of 10. So 10 equals to 2 into 5. Clear? 10 means 2 into 5. So if a number is divisible by 2 and 5 both, that number is divisible by 10. If a number is divisible by 2 and 5 both, then that number is divisible by 10. Clear? Like suppose this is a number. Suppose the number is 120. Clear? If it is divisible by 2 and 5 both, only then it is divisible by 10. So first check the divisibility rule of 2. First check the divisibility rule of 2. What is the divisibility rule of 2? If a number that is 0, 2, 4, 6 and 8. If a number that has unit digit among this number. Recall the previous session. I have discussed the divisibility rule of 2. The divisibility of rule of 2 is if a number has unit digit of 0, 2, 4, 6 and 8. Only that number will be divisible by 2. So this number has unit digit 0. Therefore it is divisible by 2. Therefore it is divisible by 2. Clear? Now check divisibility of 5. So what is the divisibility rule of 5? A number which has unit digit 0 or 5. That number is divisible by 5. So here unit digit is 0, which satisfies the condition of divisibility of 5. Therefore this number is also divisible by 5. Clear? Therefore 120 is divisible by both 2 and 5. Therefore it is divisible by 10. Clear? Next, divisibility rule of 15. So 15 is 5 into 3. The same case as divisibility rule of 10. If a number is divisible by 5 and 3 both, then that number will be divisible by 15. So let's take a number. Let's take 2 to 5. So first check divisibility rule of 5. What is the divisibility rule of 5? A number which has unit digit 5 or 0. That number is divisible by 5. So this number has unit digit 5. So it is divisible by 5. Now check divisibility rule of 3. What is the divisibility rule of 3? The sum of the digits should be divisible by 3. That is the divisibility rule of 3. The sum of the digits will be divisible by 3. Therefore check sum of the digits. The sum of the digits are 9, and 9 is divisible by 3. Therefore this number is divisible by 3. Therefore this number is divisible by 3 and 5 both. Therefore the number is divisible by 15. Clear? Now the last divisibility rule, that is most important divisibility rule of 11. Divisibility rule of 11. Now let's take a number 1 to 1. Let's take a number 1 to 1. Clear? Now the divisibility rule of 11 is, first we have to separate these numbers into odd and even numbers. Listen carefully. First we have to separate the digits of this number. First we have to separate the digits of this number as odd numbers and even number. Always write or classify numbers from your right side. While classifying odd numbers, even numbers of this number, while classifying odd digit or even digits of this number, always start from your right side with odd. Clear? Listen carefully. For the divisibility rule of 11, we have to classify the digits of this number as odd or even. So when we are classifying these digits, just try to classify the digits from your right side, starting with odd numbers. Always start with odd numbers from your right side. Always start with odd numbers from your right side. Therefore, this is odd, this is even, this is odd. Now, alternatively, you will write alternatively, starting with odd number from your right side and just alternative. Like suppose this is a number 1 2 1 2 1 2 1 2 1. Clear? So start with odd numbers and from your right side and alternate. Clear? That means start with odd number and from your right side and alternate. That means odd, even, odd, even, odd, even, odd, even, odd, even, like this. Clear? Then what will we do? Just sum of odd digits and sum of even digits. Just do the sum of odd numbers and sum of even numbers. Just do sum of odd numbers and sum of even numbers. So sum of odd numbers, just write sum of odd numbers, or sum of odd places you can write. So what are the odd places? So it is odd place, so 1. This is the odd place, this is 1. This is the odd place, this is 1. This is your odd place, 2. This is your odd place, so it is 2. So what is the sum? 2 2s are 4, 4 1s are 5, 5 1s are 6, 6 1s are 7. Clear? Now find sum of even places, sum of the digits, sum of digits at evens place. What is the sum? Now even place is 2. It is even, so therefore 2 plus here even is also 2. Here it is even 1. It is even 2. It is even 2. It is even 1. It is even, it is 1, and finally it is even, this is 1. So what is the sum? 3 2s are 5, 5 2s are 7. Clear? Now after finding sum of the digits at odd places and sum of the digits at even places, just subtract them. Just subtract them. If the subtraction gives you 0, if the subtraction gives you 0 or a number that is divisible by 11, that is divisible by 11. Just listen carefully. If this subtraction gives you 0 or a number which is divisible by 11, then this number is divisible by 11. I am repeating again. If this subtraction, that is subtraction of even places and odd places, gives you 0 or a number which is divisible by 11, then therefore this number will be divisible by 11. So the subtraction should be 7 minus 7. The subtraction is 0. Therefore, according to the rule, if the subtraction is 0 or a number which is divisible by 11, if we get subtraction 0 or a number which is divisible by 11, therefore this number is divisible by 11. So therefore, according to this rule, subtraction gives 0, therefore this number is divisible by 11. Suppose instead of 0, if we get 11, suppose instead of 0 if we get 11, then also this number is divisible by 11, because the rule is the subtraction should gives you 0 or a number which is divisible by 11. Now subtraction gives you 11 and 11 is divisible by 11, therefore this number is divisible by 11. So this is the divisibility rule of 11. Just classify the digits of the number as odd and even starting from your right side and starts with odd and just alternate. Clear? Then therefore find the sum of the digits at odd places and find sum of the digits at even places, and then subtract both. If the subtraction gives you 0 or a number divisible by 11, only then the given number will be divisible by 11. Clear? So this is the most important divisibility rule of 11. Now moving forward to our exercises. So the remaining questions of the first question is question number 7. Question number 7 says find which of the following number are divisible by 5. So the first number is 1 2 3 4 5. 1 2 3 4 5, so 6. So the divisibility rule of 5 says the unit digit should be 5. The divisibility rule of 5 says unit digit should be 5. Divisibility, just write divisibility rule of 5 is the unit digit of the number should be 0 or 5. But here unit digit is 6. Here unit digit is 6. Therefore, this number is not divisible by 5. Therefore, here unit digit of given number is 6. Therefore, 1 2 3 4 5 is not divisible by 5. This is your answer. Clear? This is your answer. Next question is your 755. So I am erasing, just say this, and I will be erased, and I will erase this. So next question number 3, 755. Clear? So clearly says this the unit digit is 5. Unit digit is 5. Therefore, according to the divisibility rule of 5, this number is divisible by 5. So just write the divisibility rule. The divisibility rule of 5 is the unit digit of the number should be 0 or 5. Here unit digit of the given number is 5. Clear? Therefore, 755 is divisible by 5. Clear? So this should be your format. Clear? Or you can divisibility rule of 5, you can just says divisibility rule of 5 says the unit digit of the number should be 0 or 5. Clear? So this should be your format of answering this type of questions. Clear? Next, question number 8. Question number 8 is which of the following number are divisible by 10? So the first number is your 9990. So to find out the divisibility rule of 10, we have to first find out the divisibility rule of 2 and then divisibility rule of 5. We have to first check the divisibility rule of 2 and then divisibility rule of 5. Only then we can conclude the number is divisible by 10 or not. So just make a heading first, divisibility rule of 2. So what is the divisibility rule of 2? The unit digit should be 0, 2, 4, 6, 8. If the unit digit of a number is among these numbers, then the number will be divisible by 2. Clear? The unit digit should be 0, 2, 4, 6 and 8. Now clearly the unit digit is 0 here, so it is divisible by 2. Clear? So just write here unit digit is 0. Clear? Therefore is divisible by 2. Yeah, now check the divisibility rule of 5. Divisibility rule of 5. Divisibility rule of 5 says the unit digit should be 0 or 5. Here also the unit digit is 0. The unit digit should be 0 or 5. Here unit digit is also 0. Therefore we can say that it is divisible by 5, and finally we can conclude that as it is divisible by 2 and 5 both, the number is divisible by 10. Is divisible by 10. So in this way we will answer this type of questions. Clear? This number you will do in your homework. 847, this number you will do in your homework. Just see, just make a heading like this, divisibility rule of 10. This number is not divisible by 2. Clear? Because the unit digit is 7. Unit digit is 7, therefore it is not divisible by 2. And in case of divisibility of 5, the unit digit should be 0 and 5, 0 or 5. So therefore the unit digit also not satisfying the condition of divisibility rule of 5. Therefore it is not divisible by 2 and as well not divisible by 5. Therefore this number 847 is not divisible by 10. So just make a heading like this and do this sum in your copy. Clear? Next question, most important, divisibility rule of divisible by 11. Question number 9. First number is 68717. First number is your 68717. Clear? So we have to classify them as odd numbers and even numbers starting from your right side. Clear? Just recall the rule. So in rough space you will write, just write the number and classify them in rough space, not on your main place. Clear? Just do it in your rough space. So classify them as odd or even. So starting with odd and from your right side. So odd, even, odd, even, odd. Now find out the sum of the digits at odd places. So after assigning the digits as odd or even, now come back to your main place. So just find out the sum of the digits at even place and sum of the digits at odd place and then subtract. So just find sum of the digits at odd places. So odd place means this is odd place 7, this is odd place 7, and this is odd place 6. That means 7 plus 7 plus 6, that is 7 plus 7 plus 6, this is 20. And then sum of the digits at even places, sum of the digits at even places. So even place means this is even place here, 1 plus 8. Two even places are there, 1 and 8. So 1 plus 8, that means it is 9. Now subtract them. Therefore if we subtract the these two numbers, we will get now 20 minus 9, it is 11. And what is the rule? The rule is, if you subtract the two numbers, this and this, subtract the two numbers, you should get 0 or a number which is divisible by 11. So we got 11, which is a divisible by 11. Clear? Therefore this number is divisible by 11. Therefore you will write, now just write in bracket, divisible by 11. We should get 0 or a number which is divisible by 11. Now 11 is a divisible by 11, therefore this number is divisible by 11. So we will write finally 68717 is divisible by 11. This is your answer. This should be done in this format. Clear? Just classify them first as odd digits and even digits, then add and then subtract and see whether it is 0 or a number which is divisible by 11 or not. Now next number is your question number 4. Question number 4, 10, 857. So do it in your rough. Just assign the numbers as odd and even starting from your right side and starting from odd. This should be done in your rough space. So odd, even, odd, even, odd. Clear? Now find out the sum of the digits at odd places first. Sum of the digits at odd places. So odd place means this is your odd 7, this is your odd, this is your odd. So 7 plus 8 plus 1, it is 16. Now find out the sum of the digits at even places. Sum of the digits at even places. Even place means 5 and 0. 5 and 0. This is even place. So 5 plus 0 gives you 5. Now subtract. So 16 minus 5, this is also 11. It is divisible by 11. Clear? So just write in bracket, divisible by 11. Therefore according to the rule, this number 10857 is divisible by 11. So this is your answer. So if you get result from subtraction as 11, if you get the result from subtraction as 0 or a number which is divisible by 11, you should get here 0 or a number which is divisible by 11. Clear? That only in that case the given number will be divisible by 11. In any other case the number will not be divisible by 11. Clear? So this is the divisibility rule of 11. In the next another question, if you get 0 over here, suppose if you get 0 over here, Clear? Then also this number is divisible by 11. So if you get 0, don't need to write divisible by 11 in bracket. If you get 0, don't need to write the divisibility by 11 in bracket. Only you will write the divisible by 11 in bracket only when you would get a number which is divisible by 11. Clear? So if you get 0, don't need to write in this bracket. Clear? Next, question number 10, divisibility rule of 15. So first question is your 8295. Question number 2, 8295, divisibility rule of 15. So divisibility rule of 15 means we have to check first whether the number is divisible by 3 or 5 or not. Clear? Whether it is divisible by 3 or 5 or not. So first make a heading, divisibility by 3. So the divisibility rule of 3 is just sum the digits of the number and see whether the sum is divisible by 3 or not. So your number is 8295. So just write sum of the digits, that is 8 plus 2 plus 9 plus 5, and the sum is 8 2s are 10, 10 9s are 19, 19 5s are 24. So 24 is divisible by 3. We know that. That is, just write in bracket divisible by 3. 8 2s are 10, 10 9s are 19, 19 5s are 24. Just write after 24 in bracket, that is divisible by 3. That means you will say that 8295 is divisible by 3. Now make a heading. We have to check the divisibility rule of divisibility of 5 also. Divisibility of 5. Now the given number is 8295. So check the unit digit. Unit digit is 5. And if the unit digit is 5 or 0, the number is divisible by 5. So you will write just here unit digit is 5. Here unit digit is 5. Unit digit, if unit digit is 5 or 0, the number is divisible by 5. Therefore we can write that 8295 is divisible by 5, as the number is divisible by 3 and 5 both. So finally we can conclude that the number is divisible by 15. So 8295 is divisible by 15. So this is your answer. Clear? This number, just do it in your homework. This number you should do in your homework, just like this. Clear? Next question. Question number 11. Question number 11 says, in each of the following number, replace m by the smallest whole number to make a resulting number divisible by 3. So question number 2, 46m46. 46m46. So the question says we have to replace m with a smallest whole number. We have to replace m with a smallest whole number so that the total number is divisible by 3. Clear? So we have to replace m with a smallest whole number so that the total number is divisible by 3. Now what is the divisibility rule of 3? The divisibility of rule of 3 says the sum of the digits should be divisible by 3. The sum of the digits should be divisible by 3. So just find the sum of the digits first. So write sum of the digits equals to 4 plus 6 plus m plus 4 plus 6. That means 4 6 are 10, 10 4s are 14, 14 6 are 20, 20 and this m. Now just think that the sum of the digit is 20 plus m. Clear? Now what can be m? What could be the m so that the number is divisible by 3? That means just read the instruction, the smallest whole number. Smallest whole number, that means m should be smallest. You cannot take m any number. You cannot take any number related to m. You have to take the smallest whole number because the question says smallest whole number. Clear? Therefore, to make divisible by 3, to make this number divisible by 3, m should be 1. M should be 1 because if m is 1, then the sum is 20 plus 1. That means 21. And if the sum is 21, then it is divisible by 3, and only then this number is divisible by 3. I am repeating again, the divisibility rule of 3 says the sum of the digits should be divisible by 3, and the sum of the digit is 20 plus m. To be divisible by 3, this should be divisible by 3. The sum should be divisible by 3. Only then this number is divisible by 3. So when this number is divisible by 3, if m is your 1, only then this sum is divisible by 3, because the question says smallest whole number. If you take m as 4, the sum is 20 plus 4, that is 24. 24 is also divisible by 3. Clear? So we cannot take 4 because the question says smallest number. The question says smallest whole number. So we have to take 1 only. Clear? M could be any number. Here m could be any number. 1, if you take m 1, that is 20 plus 1 is 21. 21 is also divisible by 3. That means it is divisible by 3. If you take m as 4, that is sum will be 20 plus 4, that is 24. In that case, it is also divisible by 3. If you take m as 7, that is 20 plus 7, 27. 27 is also divisible by 3. Then that would be your answer. But we cannot take 4, 7, all that. We have to take 1 because the question says smallest whole number. We will choose a number which is smallest. Clear? That means the m here should be 1. Clear? So just you will write to be divisible by 3, m should be 1 because the question says smallest whole number. That means the sum is 20 plus 1, 21. Clear? So what is the answer? The answer that is m would be m equals to 20 minus 20. That means your answer is 1. M is 1. Why? Because if m is 1, then the sum is 21. Clear? So we have to subtract the 21 minus this 20 and we will get your answer. Clear? The answer is your 1. The m is your 1. Clear? So m is your the sum. If you take m1, that is smallest whole number, the sum is your 21. So just subtract 21 from subtract 20 from 21, because here it is 20, here it is 20. So subtract 21 minus 20 and your answer is 1. Clear? So m is your 1. This is your answer. Smallest whole number. Clear? Next. So in this way, just do the remaining sums. In this way, just do the remaining sums of question number 11. Now question number 13. Question number 13 says in each of the following number replace m by the smallest whole number to make the resulting number divisible by 11. Same question, just it is the divisibility of 11. Just we have to check here divisibility by 11 instead of divisible by 3. So the first number is your, this is important, first number is your 7 0, this is 7 975 m. So to be divisible by 11, first check, first assign these numbers as odd and even in your rough space. Clear? Just in your rough space assign this number 70975 and m. So assigning from your right side, starting with odd. So this is odd, this is even, this is odd, this is even, this is odd, this is even. Now in min place just write sum of the digits, sum of the digits at odd places. So odd places means this is your odd place, this is your odd place, and this is your odd place. That means m plus 7 plus 0. That means m plus 7 plus 0. This is 7 plus m because 7 plus 0 is 7 and 7 plus m is 7. So find out the sum of the digits at even places now. Sum of the digits at even places. So even place means 5 plus 9 plus 7. This is even. That means 5 plus 9 plus 7. That means 5 sevens are 12. 12 nines are 21. This is 21. So now we will subtract and check whether this subtraction gives you 11 gives you 0 or number which is divisible by 11. So now just subtract. That is 21 minus 7 plus 1. This should be 0. To be divisible by 11, this number, the subtraction should be, to be divisible by 11, the subtraction gives you 0 or a number which is divisible by 11. Clear? This is the rule. But when this type of questions ask, that is replace m with a number, we will always subtract this and equal to 0. We will always subtract this and will equal to 0. Clear? This is the rule. Whenever this type of question asked in your exam, just find the sum of the digits at odd places and sum of the digits at even places, and then subtract this and equal it to 0. Always equals this subtraction to 0. Clear? Now find out m from this. Therefore 21 minus 7 minus m equal, because whenever you are opening this bracket, minus and plus will get minus. Clear? So just be careful in this step. That means 21 minus 7 is 14, minus m equal to 0. Therefore m is equals to 14. Now just this is important step. Now if m is 14, that means m is a 2-digit number. M 14 means m is 2-digit number. Now when the value of m is a 2-digit number, we should subtract this from 11. This is the rule. Just listen carefully. Whenever the value of m is 2-digit number, then always we will subtract 11 from m. Whenever the value of m is a 2-digit number, we will always subtract 11 from that number. That will be your answer. Whenever it is a 2-digit number, just subtract 11 from this, because m cannot be 2-digit number. M will always be your single digit. Clear? So whenever m is your 2-digit number, just subtract 11 from this number and you will get your answer. So therefore the value of m is, therefore you will write, therefore m is your 14 minus 11 equals to 3. This is your answer. Clear? So m equals to 3 is your answer. This is not your answer. 14 is not your answer. Your answer is 3. Clear? Now next question. Next question is next number is your 2. Next number is your 3m422. Clear? So just classify them as odd and even first, starting from your right side. Odd, even, odd, even, odd. Now find out the sum of the digits at odd places. Sum of the digits at odd places. So sum of the digits at odd places, that is, this is odd 2, 4, 6, 6 and 3s are 9. So 2 plus 4 plus 3, this is 9. Clear? This is 9. 2, 4 and 3, this is your 6 and 3s are 9. This is your odd places number. Now find sum of the digits at even places. Sum of the digits at even places, that is, even place means this is your even place 2, this is your even place m. So 2 plus m, this is 2 plus m. Now we will subtract this and will equal to 0. This is the rule. Will equal to 0 always. This is the rule. So subtract. Now 9 minus 2 plus 5, 2 plus m equal to 0. Now just whenever you are doing subtraction, you have to follow the simple subtraction rule. That means you will always subtract lowest number from bigger number. You will always subtract lower number from bigger number. Now this is the bigger number and this is the lower number. Why? Because this is 9, here it is 2, so this is the bigger number. So we will always follow subtraction rule while subtracting. That means we have to subtract lower number from your bigger number. Clear? So just open your bracket. Minus plus are minus equal to 0. 9 minus 2 gives you 7 minus 5, m equal to 0. Therefore m is 7. This is your answer. Therefore the m is 7. This is your answer. In this case we don't need to subtract 11 because m is a single digit number. Whenever m is a single digit number, we will not subtract 11 or do not go into that step. Clear? If m is a 2-digit number, only then we will subtract 11 from m, and that m, the value of m would be your final answer. Here m is a single digit number, therefore this is your answer. We don't need to subtract 11 or not. Clear? So this is complete exercise 9c. The remaining questions you will do in your homework. The chapter is complete.